Hello, and welcome to the introductory session on time, speed, and distance. You can provide your feedback via Twitter. My Twitter handle is @Ravi Handa. In the introductory session, we are basically going to talk about the standard formula, that is, distance is speed into time, how ratios and proportion can be used in this. We'll also discuss a little bit about conversion in case of units and speeds and stuff like that. To begin with, let us look at the encompassing formula for time, speed, and distance, which is distance is speed into time. If you have this, essentially you can solve any time, speed, and distance question. To begin with, the most basic idea, let us say that the speed is constant. Say you are traveling various distances over various time periods, but you maintain a constant speed of 50 km per hour, which is possible. In that case, whatever is the distance that you have traveled will be directly proportional to the time taken. That is, if in 1 hour you are covering 70 kilometers, in 2 hours you will be covering 140. In 3 hours you will be covering 210. That ratio of d1 by d2, the distance covered in t1 time and the distance covered in t2 time, this ratio will always be equal. Let's say time for a particular journey, say you are going from P to Q and you are going from P to R. The time in these two cases has gone up by 10%. Then the distance in these two cases would also go up by 10%. That essentially is what the speed being constant represents. Very similarly, if the time is constant, then the distance covered is directly proportional to speed. Very similar idea. Let's say in 1 hour, you're moving with the speed of 50 km per hour and 60 km per hour. Then the distance that you will cover in any given time, in 5 hours, in 2 hours, in 3 seconds, will always be in whatever was the ratio of the speed. 50, 60 in this case. So whatever is the distance, d1 by d2 will be always equal to 5 by 6 or whatever is the ratio of the speeds, that is s1 by s2. However, if the distance is constant, let's say you are traveling from P to Q, that distance is constant, then your time and speed will be inversely proportional, which is very intuitive. Let's say you double your speed. What will happen to the time taken? It will get halved. Let's say you increase you make your speed 3 by 5 of the original, then the time taken would become 5 by 3 of the original. It is easily represented by the formula T1 by T2 is S2 by S1. Moving on, let us look at a slightly more complex idea, but still in the field of ratios. Let's say two people, A and B, start at the same time from P and Q. As you can see here, P and Q, with the speeds SA and SB. They meet at a point R in between, and after meeting, that is for A, from R to Q he takes time TA, and B from R to P takes time TB. Then what will be the relationship between SA, SB, TA and TB? Something which can be very easily understood is that if we were talking about the entire distance PQ and QP, then simply the ratio would have been SA by SB would have been equal to TA by TB. Why? Because the distance PQ would have been a constant. But that is not the case here. Here, the distance covered in time TA and covered in time TB is different. In time TA, A covers the distance from R to Q, whereas in time TB, B covers the distance from R to P. The timings which are given to me are after meeting timings, and this is a very important idea. So to solve this, I am assuming that to reach R, both of them would take the time, which will be the same, let's say T. Why is this going to be the same? Let's say both of them started at 10 o'clock and they meet at point R at 11:20. Then both of them have taken exactly 80 minutes or the same amount of time to reach R. Now, let us try and put it in an equation format. What will be the distance PR? A is covering PR in time t. So PR will be equal to speed into time or SA into t. Very similarly, B is covering the distance QR in time t. So that will be equal to SB into t. Now, for the second part of the journey, PR or this distance, this distance RP is being covered by B with the speed of SB. So that is equal to SB into TB. Very similarly, the distance RQ is being covered by SA with the speed of TA. So QR will be SA into TA. Let's see what happens when you divide these two equations. What will happen? SA into T will be divided by SB into T, whereas SB into TB will be divided by SA into TA. As you can see from here, T will be cancelled from the numerator and the denominator. You will be left with SA by SB is SB into TB and SA divided by SA into TA. Take this SA to the other side. It becomes SA square. Take this SB to the other side. It becomes SB square. Or overall, I have SA by SB whole square is TB by TA, which gives me the formula that I was looking for. SA by SB is root TB by TA. That is the relationship between SASB and TATB. Once again, when can you use this formula? This formula can be used in only the special case when two people A and B start at the same time from two opposite ends. Their speeds are given to me as SA and SB, and most importantly, the time taken, that is TA and TB, that time taken is given to me is the after meeting timing. If that is given to me, then I can say the ratio of SA by SB will be equal to TB by TA. Now some of you may be wondering, can we also figure out the time T? Yes, we very easily can do that. Let's say if you put this equation SA by SB in equation 1 or in equation 2, it will lead you to the result that the time T which they initially took to meet is nothing else but root of TA into TB. So this is a very important formula. I request you to remember it. You don't know when it is going to come in handy. Moving on, a very simplistic discussion on conversions. Well, these are the values that you need to remember. 1 kilometer per hour essentially is 5 by 18 meters per second, or the other way around, 1 meter per second is 18 by 5 kilometers per hour. With this, I would like to wrap up this session. A brief summary once again. Distance is speed into time. If speed is constant, d1 by d2 is t1 by t2. If time is constant, d1 by d2 is s1 by s2. If distance is constant, then t1 by t2 is s2 by s1. In this case, it is reverse because it is inversely proportional. Special case, two people start at the same time. Speeds are given SA and SB. After meeting, they take times TA and TB. Then the ratio of SA by SB will be root of TB by TA and the units. If you have any feedback regarding this session or any other session, please contact me on Twitter with my Twitter handle @RaviHanda, or you can also email me on my mail ID, that is ravihanda@gmail.com. Thank you.